Hello, my name's Gary Pace. I'm a professional engineer in CWI out of Katy, Texas. This is intro to AWS D1.1. This is the second part of my review of Clause 3, where I talk about the pre-qualification of WPSs for structural steel welding code, AWS D1.1. In the first part, the first episode, we talked about approved welding processes, what a WPS is, what a PQR is, how WPSs and PQRs interact with each other. Just kind of set the table for where we're going in this second part of pre-qualification of WPSs. As I do every YouTube video that I put together, I tell you where I snagged most of the material out of the public domain, Nuclear Regulatory Commission, CANDU, the Canadian Deuterium, Uranium, Nuclear Reactor people, and the U.S. Army. And I've also pilfered some stuff from some U.S. Navy manuals. So just thought I'd throw that out there, let everybody know where I got most of my material from, and then I've just kind of added on and gone from there. All right, here's our table of contents for AWS D1.1. We're going to get into Clause 3, which is pre-qualification of WPSs, which is pretty much the meat of the welding code, of this code. Clause 3, 4, 5, and 6 to me are the heavy bulk of the code, and I guess now that they've added tubular structures, Clause 9 is pretty important. And I'm not saying Clause 1, 2, 7, and 8 aren't important, but they aren't the meat of the code to me. They're not the they're a garnish. They're the, you go out for a steak dinner, they're the side order of whatever, some kind of side salad on the side. So it's not the main courses. Pre-qualification of a WPS. Pre-qualification of a WPS welding procedure specifications shall be defined as exempt from the WPS qualification testing required in Clause 4. All pre-qualified WPSs shall be written. In order for a WPS to be pre-qualified, conformance with all of the applicable requirements of Clause 3 shall be required. WPSs that do not conform to the requirements of Clause 3 may be qualified by tests in conformance with Clause 4. For convenience, Annex P lists the provisions to be included in a pre-qualified WPS and which should be addressed in the fabricator's or contractor's welding program. So that's telling us what I've said 3 times already. You got to write it, and if you don't follow all the criteria as laid out in Clause 3, you're going to have to do a qualification, which is in Clause 4. And Annex P isn't part of this code, but it sort of is. Annex P just lists all the provisions to be included in a pre-qualified WPS. It's a little checklist that you go through and make sure you've addressed everything. And not everything is applicable to every type of weld. So when you're writing one, go into Annex P and take a look at what they got going on. Annex P, informative. Some important contents of a pre-qualified WPS. Base metal, filler metal combinations. What are you welding to what? You need to address that. Minimum preheat and interpass temperature requirements. Limitations of WPS variables. Amperage, voltage, travel speeds, whatever is relevant to what you're welding. General WPS requirements. Pre-qualified WPS variables. Shielding gases, voltage, amperage, whatever. That's listed in, I think, Table 3.8 is what it says here. Base metal for weld tabs, backing, and spacers. Heat input control for quenched and tempered steels. So Annex P is just going to line out everything you need to do for a pre-qualified WPS. And you go down through this checklist and make sure you've identified everything, write it down, double check it a couple of times, and you should be ready to go. Welding Processes 3.2.1. Pre-qualified processes. Shielded metal arc welding, submerged arc welding, gas metal arc welding, except for gas metal arc welding short circuiting, and flux cord arc welding. WPSs which conform to all the provisions of Clause 3 shall be deemed as pre-qualified and are therefore approved for use without performing WPS qualification tests for the process. For WPS prequalification, conformance with all of the applicable provisions of Clause 3 shall be required. So first off, it has to be one of these 4 processes, and you can't use gas metal arc welding, short circuiting. Once again, the processes for pre-qualification. You can use shielded metal arc welding, submerged arc welding, flux core arc welding, and gas metal arc welding in the spray or globular transfer modes. Unacceptable and need a PQR, electroslag welding, electrogas welding, gas metal arc welding, short circuit, gas tungsten arc welding, or TIG. You can use these processes with this code. They're just not pre-qualified. So you gotta, if you want to do TIG with electroslag, have at it. You just need to qualify it. You got to run a test coupon, do some bend tests, X-ray, whatever, and prove that you can run the process and get a quality result, an acceptable result that meets all the applicable mechanical properties. So you can use those processes on the far right, but you just need to qualify a PQR. You need to do a test plate, send it out to the lab, and get some results and write yourself a PQR to support your WPS. Not acceptable for pre-qualification. Base metal, filler metal combinations. Only base metals and filler metals listed in Table 3.1 and 3.2 may be used in pre-qualified WPSs. The base metal, filler metal strength relationships shall be used in conjunction with Tables 3.1 and 3.2 to determine whether matching or undermatching filler metals are required. So what's that telling us? It's telling us that you have to use a base metal that's listed in here, and you have to use a filler metal that's listed in here. You can't use something that came out of China or whatever, and they tell you, oh, this is basically A36. Unless it has paperwork that says it's A36, you can't use it. Same with filler material. It's got to be listed as an AWS filler material and fall into one of the filler material categories that's listed in Tables 3.2. So you need to make sure everything matches up. I used to review WPSs coming out of Asia, and they'd say, oh yeah, this is, we're going to use a pre-qualified procedure because this material is similar to A36. Well, it's not A36. It's something, it's, a Chinese material, a Chinese specification. It does not fall into an exact category. Therefore, it's not pre-qualified. Qualify it and then let us know. So it has to be listed there. Okay, if we look at Table 3.1, I'm not going to go through every base metal on there. We're going to hit the high points. The base metals in Table 3.1 are broken down into 4 groups, 4 base metal groups, Group 1, 2, 3, and 4. If you're looking at the table, you'll notice there's a whole bunch of Group 1 materials. Those are all your garden variety, pretty easily welded type materials. Group 2 is a little more, they're generally a little stronger, got a little higher tensile strength, a little higher yield strength. So all these materials got grouped into Group 2. Group 1 and Group 2, for the most part, are not too difficult to weld. By the time you get to Group 3 and Group 4, these are the higher tensile strength materials that they might need instead of a E7018, they'd need an E8018, or they'd need a filler material with a 80 KSI tensile strength. So Group 3 and Group 4 are stronger materials and generally a little nastier to weld. And they have different preheat requirements also than Group 1 and Group 2 do. So when you're using pre-qualification, you need to make sure that which group the material you're going to use falls into. And it's got to fit into one of these. If it's not listed in one of these base metal groups, you can't use it. So, but realize there are groupings for the base metals. Okay, if you look at Table 3.2 in AWS D1.1, filler metals for matching strength to Table 3.1. groups 1, 2, 3, and 4 metals. So remember I told you about the base metal groupings? So on the left side here, I've got base metal groups, and then I've got matching filler metals. This all comes out of table 3.2. So it's telling us that with group 1, the matching filler metals for shielded metal arc welding, and this is a simplification too. You can read it for yourself. Group 1, we can weld it with E60XX. We can use 6010, 6011, 6012, 6018, whatever. And we have no issues. We can use E70XX. We can use 7010, 7011, 7014, 7016, whatever, 7018. Not a problem. Group 1 to group 1. We can use those filler metals with those base metals. Group 2, you'll notice we've kind of upped the ante. We can't use the 60 KSI materials anymore. We can't use 6010 to weld this material. We've got to use 7015, 16, 18, or 28. This is for shielded metal arc welding, of course. And then by the time we get to group 3, we can't use the 70 series. We can't use 7018, 7028, none of that. We've got to use 8015, 8016, and 8018. So as we're going up the group metals from group 1, 2, to 3, we're increasing the tensile strength of our base material and the yield strength. So our material properties are different. So to make a sound weld metal, sound weld, and deposit sound weld metal into said weld joint, we've got to have a matching filler metal. And that's what this table gives us. It tells us what we can use with which base metal grouping. Engineer's approval for auxiliary attachments. Unlisted materials for auxiliary attachments, which fall within the chemical composition range of a steel listed in Table 3.1, may be used in pre-qualified WPS when approved by the engineer. The filler metal and minimum preheat shall be in conformance with 3.5 based upon similar material strength and chemical composition. This is where you got a clip or some auxiliary attachment. And by auxiliary attachment, I don't mean a main beam or a clip welded on there that's going to support something tangible. This is a auxiliary attachment, some little piece somewhere that needs to be welded on. That to me is my opinion of an auxiliary attachment. And if you have such an auxiliary attachment, let's say the steel comes from Lithuania and you got paperwork and you look at it and it comes out to be a group 2 steel, more or less, it falls within that category, the engineer can say, yeah, use that pre-qualified weld procedure to weld this metal to this metal. It's close enough metallurgically, mechanically, it's not going to be the end of the world. That's what 3.4 means to me, is it's, okay, this is what we're doing. It's close enough. It's not a main beam or a main component, so we can just use this pre-qualified WPS and it'll hold. Minimum preheat and interpass temperature requirements, 3.5. Table 3.3 shall be used to determine the minimum preheat and interpass temperatures for steels listed in the code. 3.5.1 Base metal thickness combination. The minimum preheat or interpass temperature applied to a joint composed of base metals with different minimum preheats from table 3.3 based on category and thickness shall be the highest of these minimum preheats. So that's telling us that if we are welding a group 1 material to a group 3 material and we're using a pre-qualified procedure, that we have to look at this table and table 3.3, and that's going to give us the minimum preheat. So as the group 2 and group 3 materials are a little more difficult to weld, and they have used 70 KSI weld material and 80 KSI weld material, they're going to need a little higher preheat. They're a little more delicate. So they're a little more susceptible to cracking. So they're going to need preheat, especially when you're welding in somewhere like Alberta. Maybe if you're welding in, Bangladesh or, somewhere in India where it never gets really cold in the tropics, you're probably not going to, really need to preheat things. You might for a thicker material, but for the most part, you're probably not going to need to. But if you're welding in Alaska or Siberia or northern China, the United States or Finland or whatever, you're going to need preheat, and you're going to need to make sure that you've addressed that preheat. So that's what it's telling us. Table 3.3, it gives you the minimum preheats. And this is based on material and thickness. So, if you've got a really thick piece of group 2 material that's 3 inches thick, you're probably going to need to preheat it, because that thing's going to act like a heat sink and suck all the heat out of your weld. And if you don't have some heat in there, you're going to have cracking issues possibly. On this slide, we can see we've got table 3.3. So it tells us the pre-qualified minimum preheat and interpass temperatures. In the left hand, it tells us our steel, ASTM A36, or way down here at the bottom, we've got API 5L, grade B or grade X42. So that tells us our material, and then we're going to weld it with stick, and then it tells us our thicknesses, and then over here on the far right, the minimum preheat and interpass temperature. So anything over 2.5 inches, we're going to need to preheat the material up to 300 degrees before we even strike an arc. That's what table 3.3 is telling us. And it's got a whole bunch of examples as we go down through it. The higher, you got group B, C, D. As you go further down, you're getting higher tensile strengths, and you're going to need different preheats that are more appropriate for those base materials and the carbon content and the metallurgy of those base materials. Importance of preheat. Section 3.5 of AWS D1.1 is explicit about minimum preheat and interpass temperature requirements. The preheat and interpass temperature shall be sufficient to prevent cracking. Table 3.3 shall be used to determine the minimum preheat and interpass temperature for steels listed in the code. It can't be understated how important preheat is, especially the further north you get. I live in Texas. It's not the end of the world down here because everything seems to be about 75 or 80 degrees most of the time. I mean, we get a little bit of cold, but not much. But I grew up in Montana, way up north, and I worked in Iowa. Or if you're in North Dakota or even up in Canada, preheat is a biggie with all these steels. So you don't want cracking. You don't want cracking when you're welding it, and you don't want cracking later on, some kind of delayed cracking mechanism. So preheat's important. So you got to follow the rules for preheat to be within the code. Importance of preheat continued. Reasons to use preheat are: it drives off excess surface moisture, hydrogen. We all know that hydrogen gets into your weld puddle, bad things can happen, cracking. You can get porosity. A lot of different things can go on. It slows the cooling rate in both the weld metal and the base metal, thereby lowering hardenability and making the weldments less likely to crack. That cooling rate in both the weld metal and base metal, it makes those areas a lot less hard when you cool it slow. So if you put heat into the part before you even start welding, a little bit of thermal energy into the part before you start welding, on the tail end after you're welding, that heat's going to be there and it's going to cool a lot slower. It allows more time at higher temperatures for the hydrogen to diffuse. Less hydrogen in the weld and base metal lowers the tendency to crack. So it allows, as those hydrogen atoms are swimming around in your weld puddle and the base metal, those guys swim faster and they want to escape. The hydrogen doesn't want to be in your weld metal. It wants to get out. And the only time it's having a problem is when it gets trapped in there and it's wanting to get out, so that it makes bubbles and cracks. So if you give it a little more time to get out and get free, that hydrogen wants to go somewhere else. It does not want to be in your weld pool. So if you give it some extra heat to get out of there, it's going to go. So you just got to help the hydrogen find wherever the hell hydrogen wants to go, and it'll go there. But you got to throw some heat into the part to do that, and this will help save you from cracking. It also helps reduce differential temperature, so residual stresses are less. You don't want a lot of residual stresses and potential warping issues, so preheat can help mitigate some of these issues. So these are reasons why you would want to use preheat. Limitations of WPS variables. All pre-qualified WPSs to be used shall be prepared by the manufacturer, fabricator, or contractor as written pre-qualified WPSs and shall be available to those authorized to use or examine them. The written WPS may follow any convenient format. See Annex M for examples. The welding parameters set forth in Table 3.6 shall be specified on the written WPS and for variables within limits within the ranges shown. Changes to the essential variables beyond those permitted by Table 3.7 shall require a new or revised pre-qualified WPS or shall require that the WPS shall be qualified by test in accordance with Clause 4. So what did that just tell us? That told us that you got to write it down. I've been telling you, just because it's pre-qualified doesn't mean you don't have to have it written down. You also have to have it available to the inspectors and to the people that are using them, the welders. You can't just go tell them, hey, weld this. The welders need to be able to look at this so they know that they're doing it right. The written WPS may follow any convenient format. You can make up your own format as long as it's understandable. They have a suggested, but if you don't use that, it's not the end of the world. Nobody's going to force you to. Table 3.6 and 3.7 are very important because they set out the welding parameters and they set out the essential variables. So Table 3.6 will tell you positions, sizes of electrodes, voltages, amperages, whatever. It's all in Table 3.6, and you need to address everything in Table 3.6 on your WPS or some linking document. And Table 3.7 is going to tell you all the essential variables that you need to address. So we'll take a look at that in the next couple. Table 3.6, Prequalified WPS Requirements. Maximum electrode diameter. It tells you for, shielded metal arc welding. What are the maximum electrode diameters that you can use for fillets, grooves, root passes in the flat position, or the maximum current. So it tells you, how much current you can use, maximum root pass thickness, for shielded metal arc welding, the maximum root pass thickness going in the overhead position is 5/16 of an inch. So that's the kind of stuff that's listed in Table 3.6. 3.7, General WPS Requirements. All the requirements of Table 3.6 shall be met for pre-qualified WPSs. So then it gives us a laundry list of things that are listed in Table 3.6. Vertical up welding requirements, width and depth pass limitations, 3.7.32 single pass fillet weld sizes. These are all the kinds of things that are listed in Table 3.6 that need to be addressed. So on your WPS, these are all important items that need to be addressed. You can't just blow them off. When I used to review WPSs, I'd hammer people for these. Fix this, fix this, fix this. You need to address this. Go to this table. So if you're submitting something for review by another party, you're going to want to make sure that you've addressed everything in Tables 3.6 and 3.7, or you're probably going to do it again and again until you do address it. Table 3.7, Pre-qualified WPS Variables. Okay, so this table tells us the variables. If you change from shielded metal arc to gas metal arc, you need a new WPS. A change in welding positions, you need a new WPS. A change in base metal group. So if you go from group 1 to group 3, you need a new WPS. You change the electrode. Let's say in shielded metal arc welding, you go from E7018 to or a new WPS. So, you just got to go through this checklist and make sure that you've addressed everything. And not every variable is applicable to every um, welding process. Things that are applicable to shielded metal arc welding are not applicable to submerged arc welding and vice versa. So table 3.7 is very crucial in pre-qualified WPSs. Joint design. Okay, here's a couple of definitions before we go further. The complete joint penetration CJP groove weld is a groove weld that extends completely through the thickness of components being joined. The primary purpose for the use of the CJP groove weld is to transmit the full load carrying capacity of the structural components that they join. The partial joint penetration groove weld is a groove weld that does not extend completely through the thickness of the joints or the components that are joined. So you got two different, acronyms, CJP, PJP. Two different types of joints that you're going to use in pre-qualified joints. The audiovisual department decided that I needed a visual here, so here you go. Complete joint penetration is the upper one. You can see it's a full penetration weld through full thickness of the two components being welded together. A partial joint penetration weld is a PJP. You can see it down below where it doesn't go completely through. It's just a partial weld. So for whatever reason, the designer decided, hey, we don't need to completely weld these two joints together. We're not transmitting the full load. We're going to save some time and money. And this is this is the joint configuration we're going to use. We're going to use a partial joint penetration weld. Which brings us to paragraph 3.12, PJP requirements. The PJP groove welds shall be made using joint details described in figure 3.2, the joint dimensional limitations described in 3.12.3 shall apply. So they give you a whole laundry list of PJP requirements. And they've got pictures of a whole bunch of different acceptable partial joint penetration welds, joints that you can use on your pre-qualified WPS. So they've got complete joint penetration joint configurations in this book. Also, they've got partial joint penetration. They've got both complete and partial listed in this book. About 25 pages worth. Here's an example of a pre-qualified joint design. This is a complete joint penetration. You can see how it goes all the way through, and then it's got a backing strip on it. It tells you the welding processes that you can use, and then all the groove preparations. You know, the root, the thicknesses you need, the how thick you need, how large you need the root gap, all the tolerances, various other sundry items that you need to complete this kind of a weld. So here's an example, but there's just dozens of these kinds of joints that are pre-qualified for use in pre-qualified WPS. Okay, summary. What did we cover? We talked about pre-qualified processes. We can't use gas tungsten, we can't use electroslag, we can't use short circuiting on gas metal arc. We have to use flux core, shielded metal arc, gas metal arc, or flux core. Those are our choices. If you're going to use something other than that, we can't use clause 3. Base metal, filler metal combinations. You have to use what's laid out for you. Gives you a certain number of materials, base materials that you can use, and certain filler materials that you can use, and you have to match those up. Knowing what your base material is and your thickness, you got to know what your minimum preheat and interpass temperatures are. You're going to look those up. You got to list those on your WPS. Oh, WPS also has to be written. You got to hit the requirements, the limitations of the WPS variables. Those are tables. Remember we talked about tables 3.6 and 3.7. You got to go through all those limitations and those WPS variables and address all of them. And make sure that for the process you're using, you've addressed all the essential variables in there. Make sure you have all the general WPS requirements addressed. The pre-qualified WPS variables, I guess I'm rehashing that again. The base metal for weld tabs, backing, spacers, that needs to be addressed. And then we didn't really touch on it, but there's heat input control for quench and temperature seals. You also need to address joint design, what kind of joint you're using, and address that. Is it a complete joint penetration or partial joint penetration? And that's pretty much it. But if you don't get confused or scared or sidetracked, and you just follow along through clause number 3, which is pre-qualified WPSs and how to write them, it's pretty self-evident. Just stay in that clause if you're using pre-qualified, and don't wander into any other clauses or chapters or whatever you want to call them. Just stay in there, stay in that little sandbox, go through the checklist, and you should be good to go. AWS D1.1 can kind of seem overwhelming at times, but you just got to stay in the little sandbox that you're playing in. Any questions, comments? You guys know how to get a hold of me. There's my website. My name's Gary Pace. I'm a CWI and a professional engineer. My focus is on welding. So if you got any questions, I know some of you have sent me texts or emails and asked questions. So feel free to do that. Sometimes I might not get back to you very quickly, but I will get back to you. All right. Take care. Have a nice day.